In today's video, we're going to run through the history of the atom. So we'll take a look at some of the different scientists that have contributed theories, and see how their experiments influenced our understanding of the atom, and how it's structured. The first major theory that had tried to explain what stuff is made out of was atomic theory, which is the idea that everything is made up from tiny little particles that can't be broken down any further, and that they're separated from each other by empty space. This was originally proposed by a guy from ancient Greece called Democritus, who was alive around 500 BC. It then took another 2,300 years, meaning the 1800s, before anyone really improved on his ideas. At this point, John Dalton described atoms as solid spheres, and importantly, he suggested that different types of spheres might make up the different elements. A short while later, in 1897, J.J. Thomson came up with the plum pudding model. He had done a series of experiments which showed that the atoms simply couldn't be solid spheres, and instead that they must have contained negatively charged particles, which we now know to be electrons. So, using this new evidence, he proposed that the atom was a general ball of positive charge, with discrete electrons stuck in it. Just a few years later, in 1909, a man called Ernst Rutherford and his students made another big discovery. What they did in their experiments is they took positively charged alpha particles and they fired them at a really thin sheet of gold. The idea was that if the positive charge in the gold atoms was generally spread out, as J.J. Thomson had proposed with his plum pudding model, then the alpha particles should pass right through the sheet of gold, because the weak, spread out positive charge wouldn't be strong enough to affect them. Weirdly though, what actually happened was that some of the alpha particles were deflected to the side, and a small number were even deflected back the way they had come, proving JJ's theory wrong. Because of these results, Rutherford suggested his nuclear model, which proposed that instead of a general field of positive charge, there was some sort of compact nucleus, which contained all of the positive charge of the atom, and he thought that the negative charge must exist in some sort of cloud around this central nucleus. At this point, Rutherford was already pretty close to how we currently understand the structure of the atom. But his model had one important flaw. Namely, there didn't seem to be anything stopping this cloud of negative electrons from rushing in towards the positive nucleus, meaning that the atom should just automatically collapse, which we know it doesn't. Just 4 years later though, in 1913, a man called Niels Bohr suggested a solution. He suggested that the electrons orbited the nucleus, in a similar way to how the planets orbit the sun, and also that they were held in shells. This idea was really important, because the orbiting of the electrons is what prevents the atom from collapsing. In the years since then, many experiments have supported this model, and it's pretty much the same one as we follow today, with just a few small changes. Further experiments by Rutherford found that the positive charge in the nucleus is actually made up of small discrete particles, which we now know as protons. And a short while later, a guy called James Chadwick provided evidence for neutral particles in the nucleus, which we now call neutrons. And that's pretty much how we understand the atom today.